Welcome to the world of infrared sensing. This small but powerful module is at the heart of countless everyday technologies, from robot obstacle avoidance to television remote controls. Let's explore exactly how it works. First, meet the IR LED, the infrared transmitter. It constantly emits infrared light, invisible to the human eye, projecting a beam forward into the environment. Think of it as a tiny invisible flashlight. Right beside it sits the photodiode, the infrared receiver. While the transmitter sends light out, the receiver listens for it to bounce back. When infrared light reflects off a surface and reaches this component, it triggers the sensor's detection logic. At the brain of this module is the comparator IC, specifically the LM393 chip. This component compares the voltage signal coming from the photodiode against a reference voltage. Based on this comparison, it decides whether an object has been detected or not. Next is the potentiometer, a small adjustable dial that gives you control. By turning it, you set the sensitivity threshold of the sensor. This determines how close an object must be before the sensor registers a detection. The remaining components complete the circuit. The power LED confirms the module is receiving voltage. The output LED lights up whenever an object is detected. VCC and GND are the power supply pins. And the out pin sends the detection signal directly to your microcontroller. Now let's see the sensor in action. The IR LED constantly fires pulses of infrared light at a frequency of around 38 kHz. This light is completely invisible to our eyes, it sits just below the visible red spectrum on the electromagnetic scale. When there is no object in the sensor's path, the infrared beam travels forward and scatters into the environment. The photodiode receives little to no reflected light. The comparator keeps the output signal high, meaning no detection. Now place an object in front of the sensor. The infrared beam strikes the surface and reflects back. The photodiode captures this reflected light and its resistance drops sharply, generating a voltage change that the comparator immediately reads. Here's where the LM393 comparator earns its role. It takes two voltage inputs, the signal from the photodiode and the reference voltage set by the potentiometer. When the reflected light brings the photodiode voltage below the reference threshold, the comparator flips its output to low, signaling object detection to the microcontroller. Let's bring the complete picture together. The IR LED fires. The beam bounces off an object. The photodiode detects the reflection. The comparator makes the decision. The out pin delivers the result. And the microcontroller takes action. 5 steps. 1 seamless system. IR sensors power a wide range of real-world applications. Robots use them to detect and avoid obstacles in real time. Remote controls transmit command signals using infrared pulses. Automatic dispensers and faucets use IR to detect your hand without touch. The list keeps growing. Line-following robots read black and white surface contrast using IR sensors. Security systems detect intruders by sensing broken infrared beams. And medical pulse oximeters use infrared light to measure blood oxygen levels right through your fingertip. Before you deploy an IR sensor in your project, know these key specs. It operates on 3.3 to 5 volts. Detection range spans 2 to 30 centimeters. In direct sunlight, which can overwhelm the photodiode with ambient infrared. They cannot detect transparent or highly absorptive black surfaces. And their reliable detection range is limited, typically under 30 centimeters. From a simple beam of invisible light to intelligent real-world detection, the IR sensor is a masterpiece of practical engineering. Small, fast, affordable, and everywhere. Now you understand exactly how it works.